My hope today is to tell you something about instantaneous rate of change. Before we do that, I want to connect again mathematics to the real world by looking at how we use some of the concepts we've seen in physics. Average velocity in physics is the same thing that we've been looking at in terms of average rate of change, slope of secant line, whatever you want to call it. To understand what calculus is, you have to understand that real-world processes are often represented by functions. And calculus is a toolkit for understanding how those functions change or how those processes change by looking at the graph of the function or the formula of the function and determining things about that function. Calculus can be applied to any situation where something is changing. It's easiest to start by thinking about physical motion, by something moving around. And we're only going to be able to work in this class with something moving in one dimension. In physics, the displacement or position of a body in motion is where it is in relation to some starting point. So whenever I do a motion problem, I have to look at what is the starting point, like where is zero, and then which direction is positive and which direction is negative. Additionally, I'll need to specify what time we're considering zero. Don't forget to do these things when you do motion problems. You always want to specify an origin or starting point in both time and space, and always specify a direction. It does not matter what you call zero, as long as you're consistent. It doesn't matter what you call the positive direction, the negative direction, as long as you keep it that way through the entire problem. So let's look at an example of this. The other day, I drove my children to the park in Waynesville. And so you can get from Waynesville, from Cullowhee to Waynesville in about 30 minutes. It is 23 miles. Now, I probably got there in about 30 minutes. So about 4 p.m., I left Cullowhee for Waynesville. At 4:30 p.m., I arrived in Waynesville. Then from 4:30 to 6 p.m., I played at the Waynesville Park. And from 6 to 6:30, I drove from Waynesville back to Cullowhee. I was in motion. In order to express this mathematically, I need to say, what was the zero of my motion? So I'm going to say that the zero here was Cullowhee. And I'm going to say that the positive direction was Waynesville, which means if I had gone the other direction away from Waynesville, it would have been negative. So now I can use this idea to translate this into a function. My reference points are going to be that Cullowhee is zero, that 4 p.m. is the zero in time. My directions are going to be that the positive direction is towards Waynesville from Cullowhee, and the negative direction is away from Waynesville. With this in mind, I keep moving on and I can answer some questions. If I call this function P of X, it tells where I was, displacement, X hours after 4 p.m. on this day. I can look at this question, what is P of 0.5? So what this is asking is, in words, what this is asking is, where was Dr. Penland's 0.5 hours after 4 p.m.? Because X is 0.5, and it says that this displacement is X hours after 4 p.m. Well, 0.5 hours after 4 p.m. is the same thing as saying 4:30 p.m. So where was I in terms of, I notice I'm actually doing something bad here. I should have a unit for my displacement as well. So let's say that I'm measuring displacement in miles. And that's arbitrary, but of course we usually work in miles, so there's nothing too exotic about that. Well, at 4:30, I was in Waynesville. And we saw that Waynesville was 23 miles away. So you would say P of 0.5 equals 23. And if you wanted to be really careful, because we are dealing with units here, you might even say P of 0.5 hours equals 23 miles. Although that's not common, it would not be wrong, and it might be good. So this P of 0.5 equals 23 means the same thing as saying at 4:30 p.m., Dr. Penland was 23 miles away from Cullowhee in the direction of Waynesville. Now, a second question we could ask is, what are the x values where P of x equals 0? Notice this is a very different question than asking what is P of 0.5. These are very different things, and it's important to understand the difference between them. So the difference between them is whether we're interested in knowing, in this question, we knew the time, and we wanted to know the displacement. Here we know that the displacement is 0, but we don't know what the times were. So an equivalent way to ask this question would be, at which times was Dr. Penland 0 miles away from Cullowhee? And depending on how technical you want to get with measurements, this is obviously something we're doing on kind of a rough level, but definitely at 4 p.m. I was in Cullowhee, so at x equals 0, because again, x is hours after 4 p.m. and I'm back in Cullowhee at 6:30 p.m. So that's at x equals 2.5. That's an x, not a t. Now we can ask about average velocity. Remember that average velocity is just a change in position over time, but it's important to remember that position can be positive. The change in position can be positive or negative depending on which way we're going. Since our formula is p of x, we can write the average velocity on the interval AB as this p of b minus p of a over b minus a. And you'll remember this is the average rate of change formula. And that's exactly the key idea here, is that average rate of change is the same thing, or average velocity is a special type of average rate of change. So everything we have learned so far about average rate of change carries over when we talk about average velocity. So here are some questions about this example. What was my average velocity from 4 to 4:30 p.m.? Remember, we're moving in the positive direction. We're moving from Cullowhee to Waynesville. We decided from Cullowhee to Waynesville was positive. So we went forward 23 miles. So we have plus 23 miles divided by 0.5 hours, which gives us 46 miles per hour. What was the average velocity from 6 to 6:30 p.m.? Well, from 6 to 6:30 p.m., I was going from Waynesville back to Cullowhee. And so I was going this direction. If we think of Cullowhee as 0, then Waynesville was at 23. I actually went negative 23 miles because I went from 23 back to 0. So it's important to remember here with displacement, there's going to be a direction. And if you're going from a positive number to 0, that's negative motion. So the average velocity here is negative 46 miles per hour. I can't emphasize enough that velocity can be negative. Then final question, what was my velocity from 4 to 6:30 p.m.? Well, let's think about this. What was the change in my position from 4 to 6:30 p.m.? At 4 p.m., I was at time 0. At 4 p.m., I was at 0. And at 6:30 p.m., I was at 0 because we agreed that Cullowhee was 0. So there was no ultimate change. I traveled 0 minus 0. And I had a change in time of 2.5 minus 0. But the ultimate answer here is 0. 0 is in the numerator. So this is equal to 0. So even though I traveled quite a bit, my average velocity was still 0 miles per hour because I went as much negative as I did positive. So I hope this helps a bit with understanding average velocity. It's an important conceptual idea, and we're going to need it now that we move into discussing instantaneous velocity.